So the second question, we say, do they have the same denominator? No. What do 10 and 5 both go into? 10. You want the lowest common number that you both go into. You could do 50, but then you're going to have to reduce more at the end, so you're kind of giving yourself more work if you pick a bigger number. But the lowest one is the easiest. So if I make them both into 10, I can add them, but that one's already 10, so I don't have to do anything with 7 10. But to this one, I have to multiply by a value of 1, multiply by 2 halves. Get 16 tenths, add them together, and I get 23 tenths. We have 3 28ths, subtract 1 4. So you say, what do 28 and 4 both divide into? 28. So you multiply this one by 7 tenths. There's 3 28ths, subtract 7 28ths, and you get negative 4 28ths. A lot of you have that, but I didn't give you a check mark. Because now we have to do what we've been doing and reduce it. So I'm going to factor negative 4. That's a negative 1 times 4. And I'm going to factor 28 to be 7 times 4. If you factored it, then you can cancel. You factor it out and you can cancel it. So you're negative 1 7. All right, the next three are called complex fractions. They're called complex. They have a fraction inside of a fraction. They're called complex. So what I'm going to do first is I'm going to subtract the numerators and find like one fraction on top first. So 3 and 2, our common denominator would be 6. So this one I multiply by 3/3. This one by 2 2s. Multiply straight across, I get 4 6 minus 3 6. Which gives me 1 6 over 3 6. The next step is what we learned last class, where instead of dividing by a number, you can multiply by its reciprocal. So what I'm dividing right now is I have 1 6 and I'm dividing by 3 fifths. So when I change that to multiplication, I will have 1 6 times 5 thirds. Near 5/18. This step right here, a lot of people skip. But then this step right here is where some people make mistakes. So I'm writing it out. You can choose to write it out or not, but that's the step where people make mistakes. So the next one, same thing. We've got 5/8 or negative 5/8 and 3/4. So what denominator do 4 and 8 both divide into? Any multiple of 4 or 8? 8. So I will multiply this one by 2 halves. Negative 5/8 minus 6 8. We get negative 11/8 over 2. So again, this step is the step where people make mistakes, the step that I'm about to do. So what I'm saying to myself is I have negative 11/8 divided by what number? 2. I have negative 11/8 divided by 2. So when you change it into multiplication, you have negative 11/8 multiplied by a half. So you get negative 11/15. So that step I started is the one that people make mistakes on. Okay, and then the last one. You do not need a common denominator through the whole thing. You can, but you don't need to. If you just do the top and bottom separate, it's good. It's fine. So on the top, I'll make it 10. And then on the bottom, what's my denominator? 4. 1. So I have to make it into a fraction, and then I'm going to make it both 3. So I've got 25 tenths, subtract 14 tenths, over negative 2/3 plus 12/3. Keep the same denominator, subtract the numerators. Keep the same denominator, add those numerators. Now I'm dividing. So I'm going to think, or I'm going to write division. 11/10 divided by 10/3. I just wrote it as division. This is the step people silly mistake on. Now I change it to multiplication. 11/10 multiplied by 3/10. Go straight across, you get 33/100. Not once did I make a mixed number. That's extra step you don't know. You don't have a reason to do it. It's just extra work. So I wouldn't do a mixed number. Okay? So if you can do this, you can do it with variables as well. Ready? Turn the page. Oh, it's baby steps today, dear. It's baby steps today.
There's one variable. So X, Y, Q's, R's, T's, now it's
Baby steps. All right, so the first question you look at it, we're doing addition, and what's the rule for adding? No. What's the rule for adding? We just did it on the front page. You have to have like terms. Anytime you add a math, like terms. So with fractions, common denominators. Do we have common denominators? So then we have the answer with a common denominator, and on top we add 7 plus 3. So 7 plus 3 is 10 over our common denominator for x. So it's a factor. 10. 4. 2 times 5, 2 times 2 times x. If I factor it, and they're the same factors, we can cancel. And if you did your assignment last night, you just did a ton of that. Now, check our domain restrictions. In the original question, domain restriction, x cannot equal 0. At the end, x cannot equal 0. Was there any domain restriction I don't see? That happened earlier and I don't see it now? No, then I do not write anything extra. So notice I did not put that as part of my answer. Just that, because I already know x is not equal 0. So B, first thing you say, what am I doing? I'm doing subtraction, which is the same as addition. What are my rules for adding in math always and forever? Not always denominator. Not always common denominator. Always like terms. You have to have like terms to add. Now when we talk about fractions, we need common denominator. That is our like term. So do we have common denominator? Yes. Now we subtract our numerator. 2x minus 5. Now, 2x subtract 5. Are those like terms? So then I cannot combine 2x minus 5. I must leave it as a binomial. So now we see if we can factor it. And you have to think, when you do factoring, you factor the entire binomial. And what are our rules for binomial factoring? First rule always. GCF. With a binomial, is there a GCF? Okay, so can we factor further? Is there like 2 parentheses because there's a squared in there somewhere? Is there cubed in there? Okay, this is not factorable. How about in the denominator? X plus 6. First, is there GCF? Can I write like 2 parentheses? No, because it's just x to the first power. This is not factorable. If it's x to the first power, it's not going to factor further other than maybe a GCF. So at this point, I can't cancel anything. I cannot cancel those x's. I cannot cancel the 2 or the 6. Because nothing's factored. I have to be factoring the binomial, not individual terms. So this is it. Did our domain restriction change at all? We didn't need to cancel anything, so you don't need to include anything. All right, I have 4 U tries. Yes?
What's wrong with it? So included the answer?
Yes. Okay. You only include it when it disappears and you wouldn't already know it by looking at it. Alright, so you have 4 U triangles. This one is. So we just say this, not that. Don't do the diagonal thing, then I can't tell where the X goes in. What about this one? We'll use it. And then the next one. Three can become a 5 a little bit. We'll go over in a moment. Walk around and see if anybody else has other answers. If I walk past you and I didn't check it, then it's not right. Four checks, the first one. Make one last little pass around the room. Four checks. Four checks. All right. Why are you not reworking any of this around, right? Well, you're doing it too fast because you're making slow mistakes. Okay, the first one, we look and we say, yay, common denominator is 12x. So now I do 8 subtract 5. 3 over 12x. Then I say, does anything factor? Well, 3 is 3 times 1, and 12x is 3 times 4 times x. So I can cancel the 3 and the 3 to give me 1 over 4x. Number 2, same denominator. 3x squared. On top, 2 plus 1 is 3. Does anything factor? With monomials, with one term, we just pull the sum apart. 3 times 1, 3 times x squared, or x times x. And we'll have 1 over x squared. That's the rules of factoring monomials. It's different when you get to binomials. Number 3, same denominator, x minus 2. On top, we have to do 4x minus x. And then you say, 4x, subtract x. Are these like terms? Yes, if I have 4 x's and I take away an x, How many x's do I get? 3 x's. So on top, I can factor 3 times x. On the bottom, it's a binomial. Quit touching him. On the bottom, x minus 2 is a binomial. How do I factor binomials? First step, GCF. No? If it's to the first power, you can't factor it further. So that's not factorable. I cannot cancel anything because I did not factor it. This will be it. So Tim, what did you do wrong on that one? You did? Well, then I couldn't read your handwriting. It looked like 5x to me. Okay. I was asking you before, go back and look at your work. Why didn't you find a mistake yet? I thought it was 5. All right. Then the last one, we have the same denominator. And then we add our numerators, 2x squared plus 2. And you say, can I add together 2x squared plus 2? Are those like terms? No. So then that's as far as I can add them. Next question, can I factor? The numerator and the denominator are both binomials. What's my first step for factoring a binomial? Is there a GCF on top? So we take out 2. We're left with x squared plus 1. Now, can I factor x squared plus 1? If I can, it's going to be like x with something, x like 2 parentheses, x that makes this. Here's another way of knowing if it's factorable. Can you solve it? Well, we gotta figure out the domain restrictions anyway, so let's see what happens when we go to solve it. X squared does not equal -1, then what do we do? Square root it, so I get x does not equal plus minus square root -1, what do I get? Imaginary numbers. So first of all, there's no domain restrictions because that's not a real answer. And then second of all, that tells me I can't factor this because I won't get a real answer. It's not factorable. Happens all the time. I don't know why. All right. So what do I do now? Just cancel it, right? It is factored, so I can cancel it, and then I just get my answer of 2 with no domain restrictions because they're imaginary. All right. So that's. Yeah, we got 2 more examples to do, but that's part of what you're going into. And then the last 2 examples is how to find the least common multiple of stuff with x's. How to find the least common multiple. So we've already done this on the first page. You were finding like lowest common denominator. That's the least common multiple, but that was with numbers. This is how we do it with the x's. I'm going to have steps. Step 1. Factor each expression. Factor each expression. Factor each expression. My first expression is 4x squared minus 16. I need to factor that. It is a binomial. How do I factor binomials? Is there a GCF? So 4 multiplied by x squared minus 4. Does it factor further? It's a difference of squares. Also, 4 factors further. 2 times 2 times x minus 2 and x plus 2. So those of us that have been doing our assignments, these factoring should be getting like easier and easier, and you should see it really fast if you've been keeping up on your assignments. All right, the next one, how do I factor a trinomial? First step. Is there a GCF? Yes. So 6 multiplied by x squared minus 4x plus 4. Now that will factor further. My 6 becomes 2 times 3. And then we do 2 parentheses, and we do guess and check. We get x minus 2 and x minus 2. And I'm leaving them separate right now because of what we're going to do next. I'm purposely leaving them separated. So that's step 1, factor. Step 2, we're going to write any common factors once. Oops. Once. So we're going to find our LCM. Any factors between the two expressions that are the same, we copy them once. So looking side to side, what's the first factor that is exactly the same in both of them? 2. I like to circle it, and then I write it down here, but I only write it once down there. So those are in common. What else, if anything, is in common? X minus 2, just one of them from each. So we bring it down and we write x minus 2. Is there anything else in common? So then what I do is step 3. Write all other factors. So everything left is not in common. You're going to write it all. So I like to mark them as I go so I don't miss any. So 2, and then x plus 2, and then 3, and then x minus 2. So I went through and I marked all of the ones that were not in common. And I moved them down to the LCM. And then finally, you're going to simplify your LCM a little bit. So I'm going to multiply together 2 times 2 times 3, 12. The x minus 2 and the x minus 2, I'll just make that x minus 2 squared. And then I'll bring down that x plus 2. I'm not going to FOIL all that out. That's ridiculous. Just leave them as separate factors. But things like 2 times 2, I can multiply together. Okay? So eventually we're going to be finding common denominators with things that don't have common denominators. This is the first step of that. So you really need to know how to do this. This lowest common multiple thing is going to be very important. So let's try one more, and then we'll be done. One more. Find the least common multiple of 5x cubed and 10x squared minus 15x. Step 1. This is our step 1. Factor each expression. So the first expression is a monomial. So factoring 5x cubed, we just write 5 times x times x times x, 5x cubed. The second expression is a binomial. So how do we factor binomials? First step. Is there a GCF? What is it? It's 5x. So factor out that 5x, and we have left over 2x minus 3. 2x minus 3, does that factor further? Is there a GCF with 2x minus 3? Is x to the first power? It is the first power, so I'm going to factor further. So we have that factored. Step 2. What's step 2 say? We're going to look at what they have in common, but only write it once. So looks like they both have a 5. What else do they both have in common? And X. Anything else they both have in common? No. So we go on to step 3. Write everything else that I didn't circle. So x times 2x minus 3. And then let's just simplify it, put it together. We'll have 5x cubed multiplied by 2x minus 3. Your assignment is a worksheet that has questions like that on it. And then when you get to the back, you just have some review questions. There's a couple of graphing ones and a couple of the stuff that you've been doing the past 2 days. The other assignment we haven't graded yet. So if you had questions on that, you can ask questions before you leave. If it's done, you're good to go. If it's not done, you better get on that and make sure it's completed by Monday.
All of it.
I mean, the odds is what you need to do, but remember I told you what I'm going to do with those events.